In this video, we are going to discuss on DC circuits. The DC circuits, we are going to discuss on the topics Ohm's law, Kirchhoff law, analysis of series, parallel circuits, and also power and energy. Let us take up Ohm's law first. So understanding why it is not an actually physical law is critical to understand the basic principles of logic and the nature of physical law. So whenever the force is being applied, the voltage is nothing but here the force, in terms of force applied, the current flows. So when you apply a voltage, the current flows. So let us define the Ohm's law. Ohm's law definition is, it states that the potential difference across the resistance is proportional to the voltage provided, temperature remains constant. V is directly proportional to I. If you remove the proportionality constant, we can say V is directly proportional to I. If I remove this proportionality constant, then V is equal to IR. So we can state that R is a proportionality constant. So definition of Ohm's law is also defined as the resistance which permits the flow of 1 ampere of current when a potential difference of 1 volt is applied to the resistance. So all we need is, we need a resistor, we need a voltage, then only the current flows in a closed circuit. So remember, very important note is, when we give a voltage, current only flows in the circuit which consists of a resistor when it is a closed loop. So closed loop here I mean it is a complete closed loop. So when I apply a voltage, for example, let us say I am applying a voltage to this circuit and we have a resistance here, the current flows here. So if you see, this is a closed circuit. Then what do you mean by open circuit? So open circuit here is nothing but you don't have a closed path here for the current to flow. So the closed circuit, the open circuit can be written as this way. If you make a note, this is a open circuit. So if I have a applied voltage here and if I leave anywhere the line open, so the current doesn't have a path to complete the flow of the current in the circuit. So this is all about the definition of Ohm's law. Next, let us come up with the limitations of Ohm's law. Ohm's law is not applicable to nonlinear devices such as diodes, Zener diodes, voltage regulator, etc. So it is not applicable to basically for the devices in a circuit having diodes, Zener diode, and voltage regulator. Now the other limitation is, it does not hold good for non-metallic conductors such as silicon carbide. The next principle is Kirchhoff current law. So if you look at this diagram, so if you can notice the red thing which is entering the junction. So this is the junction. We have the junction point. This is a junction. So the center point is a junction. So current entering the junction, if you can see the arrow marks moving towards the junction, is leaving away from the junction. So KCL can be defined as the algebraic sum of the currents meeting at a junction is 0. That is, sum of the incoming current is equal to sum of the outgoing current. This is all about Kirchhoff current law. So we can write the summation, the sum of current can be written as summation of I is equal to 0. So if you look at this example, the current I1 entering here, I2 entering here should leave I3. So in this case, I can write the current I1, plus the current I2 is equal to current I3. So as per the definition, the summation here refers I1 plus I2, okay, summation. So if I take the incoming current into the junction, this point is positive, the current leaving this point is considered as negative. So if I say this is I1 entering the current that is to this junction, and I2 is entering to this junction as positive, the current leaving this junction should be considered as negative. So we can write minus I3 is equal to 0. So if you transfer this I3 to right hand side, so we can say sum of the current entering the node is equal to sum of the current leaving the node. So this center point is called as a node. This is all about Kirchhoff's current law. So next, coming up with Kirchhoff voltage law. The Kirchhoff voltage law defines as the algebraic sum of the voltage or the potential drop in a closed circuit is equal to the EMF acting on the circuit. Now if you look at this, the potential drop here means the voltage. Okay, we refer always the potential with respect to voltage. Now why it is the potential drop is always measured between two terminals. Suppose if you take the resistance here, and if I have to measure the voltage, so these are the two terminals. We say between these two terminals we measure the voltage. So this I can connect a voltmeter here to measure. So voltage potential drop across the terminal or between the two terminals is the meaning that we connect a voltmeter to measure across these two terminals. So the algebraic sum of the potential drops in a closed circuit is equal to the EMF acting on the circuit. So now this is the EMF acting on the circuit is 10 volts. The potential drop in the closed circuit across this resistor is 5 volts and another resistor is 5 volts. Put together, the sum of the potential drop is 10 volts in the closed circuit, that is equal to the EMF, that is 10 volts acting on the circuit. Here 10 volts is the EMF or electromotive force. EMF is the meaning we have electromotive force, which is nothing but voltage or a potential drop, so which is equal to the drop across these two resistors. So voltage applied should be the drop equal to the drop across the resistors in a closed circuit. So if you take up this closed circuit, so this we can write here. So sum of the potential drop means summation of V is equal to 0. So the voltage drop is equal, sum of the potential drops in the closed loop is equal to the EMF acting on it. So we can write here 10 volts minus 5, okay, minus 5 is equal to 0. This is the algebraic sum of the voltage. So if you take this minus to plus here, how do you consider the sign here? So as I explained with the KCL, here minus to plus is positive. So increase, this is the increase in drop. So increase in drop is always considered as positive. So if this is considered as positive, observe the polarity here. The current direction is in this way. Looking at the current direction, you need to assign the polarity, that is positive and negative. So we know always the current flows from higher potential to lower potential. So when higher potential always refers with positive and lower potential always refers with negative. So when you take the current direction in this way, this is the higher potential. So plus to minus, the drop is now, it is towards decreasing. So plus to minus means it is decreasing. So we can write it as minus 5. And again, if you observe, the current is flowing here. So the potential is here high and low at other end. So the current flows from this direction. So again, the potential is now decreasing here, plus to minus. So we can take minus 5 is equal to 0. So according to our definition, this can also be written as the algebraic sum of the drops means it is 5, okay, plus 5 is equal to the EMF acting on the circuit, that is 10 volts. So this is all about Kirchhoff voltage law. In the next class, we can take up analysis of series and parallel circuit.